Hey students, this is lesson 3.3. In this lesson, we're going to learn how to use multiplication or division to solve inequalities. Go ahead and do the review, and I'll check back with you. So we're trying to learn how to use multiplication or division to solve inequalities. There is a slight problem with that. And the problem is sometimes the inequality symbols reverse direction. And we're going to do this little problem here just to figure that out, when they reverse. Once you know that, then solving inequalities is the same as solving equations. So we started with this inequality, 4 is greater than 1, which is true. And now we're going to do some different things to it. We're going to multiply both sides by the same number. And we're going to keep changing the numbers just to see what happens. So 4 times 3 is 12, and 1 times 3 is 3, and 12 is greater than 3. 4 times 2 is 8, 1 times 2 is 2, 4 is greater than 8. 4 and 1, 4 is greater than 1. Negative 4 and negative 1, here's where we have a little bit of a problem. Negative 4 is not greater than negative 1. So I actually have to, when I multiply by negative 1, I have to reverse the inequality to keep it true. 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. Negative 8 is less than negative 2. And again, on this last one, you can see that negative 12 is actually less than negative 3. So if you watch that carefully, you probably noticed that whenever we multiplied by a negative, both sides, we ended up with an inequality that was reversed. And that concept is right here. As long as you're multiplying both sides by a positive number, the inequality symbol stays the same, and that's what this is showing. If C is greater than 0, so a positive number, then if you start out with an inequality where A is greater than B, then multiplying A times a positive number will be greater than B times a positive number. But if C is less than 0, the opposite is true. You end up with, if you start with A as less than B and you multiply by a number less than 0, you're going to end up with the inequality symbol reversed. And that's shown right here. All right, so go ahead and fill in these problems here and keep that in mind. I want to pay a little bit more attention to the second part here. So if A, B, and C are real numbers with C less than 0, in other words, C is negative, then if A is greater than B to start with, when you multiply by C, and C being a negative number, you're going to have A times C is less than B times C. So notice the inequality symbol changed when we multiply by negative. All right, so, and we'll show that here. So if we're actually, it says we're dividing by negative 2 here, or you could think of it as multiplying by negative 1/2. So you get negative 3 on this side, and you get negative 2 on this side, and negative 3 is less than negative 2. And if you start with 2 is less than or equal to 3, which is true, and you multiply both sides by negative 5, you're going to end up with negative 10 is greater than or equal to negative 15. And this last one, dividing by negative 3, which is really the same as multiplying by negative 1/3, you're going to have to switch the sign. So 4 is now greater than 3. So if you start with less than and you divide both sides by a k that's less than 0, you're going to end up with
Natasha or Michelle, would you come to the...
So we have to reverse the sign. So we started with less than, we're going to now have greater than. All right. So what are the solutions of x divided by 2 is less than negative 3? To solve this, we are going to multiply both sides by 2. And when I multiply both sides by 2, I'm going to end up with x is less than negative 6. I didn't have to change the sign here because I multiplied by a positive number. Then I'm going to graph that. So I'm going to, since we have just less than, I'm going to circle negative 6. And I want all numbers that are less than negative 6, which will be to the left of them. So over here. And just to check that, make sure I'm right. The way I would do that is I would plug in negative 6 for x, substitute it for x, and make sure that that equals negative 3 because that's my boundary, my endpoint. And negative 3 is equal to negative 3, so that's good. The other thing I would do is choose some number in here in my solution set, like negative 8, and try that. So negative 8 divided by 2, make sure that is less than negative 3. And that's negative 4, and negative 4 is less than negative 3, so that checks. All right, you try it. All right, we're going to do this activity in class, or we did this activity in class, something like that. So what are the solutions of negative 2/3 times w is greater than or equal to 2? I'm going to solve this by using multiplication property of equality. Of inequalities, I'm going to multiply both sides by negative 3 over 2. And when I do that, when you multiply both sides by a negative, we have to reverse the sign. And that gives me w on this side is less than or equal to 2 times negative 3 is negative 6 divided by 2 is negative 3. Those two actually cancel nicely. So I get all numbers less than or equal to negative 3 for my solution. So I'm going to put a solid dot on negative 3, and less than is going to be to the left this way. To check that, my boundary point is negative 3. So 2/3 times negative 3 should equal 2. And that is equal to 2, and negative times a negative is positive, so that checks. And then I'm going to check some number inside my solution set, like negative 4. Actually, I want to pick a number that I can multiply by negative 2/3 real nice, like negative 6 in my solution set. So I'm going to do 2/3 times negative 6. Make sure that's greater than or equal to 2. And 2/3, a negative times a negative is positive. And 2/3 of 6 is 4 because 1/3 of 6 is 2. And 4 is greater than or equal to 2, so that checks. All right, you try that. Okay, the division properties of inequality are exactly the same as multiplication. If you divide by a positive, the sign doesn't change. If you divide by a negative, the sign does change. It reverses. So think about that when you're dividing. Here's a problem we're going to do, and we're going to represent this as an inequality. The cheerleading squad earns $5.50 per car washed. How many cars does the squad need to wash to earn at least $77? So let's let C be the number of cars they wash. So the amount they earn is 550 times C, and at least means greater than or equal to 77. So we're just going to divide both sides by 550. That will not change the inequality. And we get C is greater than or equal to 77 divided by 550, which is, let's see, 77 divided by 11 is 7, and 550 is half of 11. So 77 divided by 550 is 14. So they must wash at least 14 cars. All right, you try that. All right, one more problem to do here. What are the solutions to negative 5a is greater than 20? And to solve this, we want to divide both sides by -5. When you do that, you're going to have to reverse this inequality sign. So you get a is less than or equal to -4. And so I'm going to put a solid dot at -4 and shade to the left. And I'm going to check that, make sure -5 times -4 equals 20. And that's true. Good there. Got my endpoint right. And then I'm going to choose something like -10 in my solution set to see if all my solutions are right, and make sure that's greater than or equal to 20. And that's 50, and 50 definitely is greater than 20, so I think that's good also. All right, go ahead and do problem 4. All right, there's your answer there. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.